Turns off? Anyway. Okay, ladies and gentlemen, I have no idea what the situation is. This morning I went to G5008. Things didn't work there. So I don't know what to tell you. I don't know. We'll see how it goes. Next week, just to let you guys know, we're not going to have class next Monday. Okay, I will be in Sacramento at a conference on disenfranchisement of students of color due to various legislation that is affecting math education, education in general. So I'll be there. And then on Monday, that's on Sunday. On Monday, I'll be talking to legislators. Okay, so there's a lot going on. So that's where I'll be at. I'm not fooling around. I wish I was in Maui. God, I'd rather be at Maui. Yeah, yeah, exactly. That sounds a lot funner than having to talk to legislators. Politicians who don't listen. It's always about what's best for them. You know. So anyway. So that's where I'll be. I'd rather be in Maui. Is there any place better to be in than Maui? Cancun? You like Cancun? I like Cancun. Japan? Yeah, I haven't been there. I'd like to see Japan. Good food, I bet. That's what I hear. Good food.
10 days wasn't enough.
10 days? Really? It wasn't enough? All right, well. Anyway. All right, so I'll be in Sacramento. Is it raining out there?
My dad lives up
Have you been out there, Sacramento?
there. Yeah, I've been all around the north area.
What place do you like out there?
Well, we used to live in a little farm town. It's called Williams. It's like on the 5 going up to
Uh-huh.
like Oregon. Yeah.
What's you like that town?
Yeah, it's nice and quiet.
What town is it called?
Williams. Also Calusa. I don't know.
There's a lot of, just that drive up north.
Yeah.
Not on the coast. I guess it's the 5. It's a lot of kind of neat little towns.
Yeah, there is.
Beautiful. But I think they're having problems with the weather, with the flooding and everything and all that stuff. A lot of places in California. So, yeah, I'll be out there doing that thing, talking to politicians and in a conference. And so it's not like you're going to have fun out there. You know what I mean? It's not like you're going to Vegas. Anyway. All right, ladies and gentlemen, let's get started. Did you guys try this out by any chance? This is gender sequence. I want to test you guys on, do you guys know the definition of what? Probability. Okay, so let's go with this. What are they asking you here, ladies and gentlemen, when they say, what's the probability of having what? What's the phrase? No boys? So remember this. We need to use the definition of probability. What's your definition, by the way? Probability of an event. What is that? Do you guys know? Huh? It's the number of outcomes in your event divided by the total number of possible outcomes. Is that right? So the easy question is this. You have to know the sample space. How many outcomes are in the sample space? What is N of S? How many outcomes? 4. Good. Good job. 4. So what does that mean about every one of these questions? For every one of these questions, the denominator is going to be what? 4. Now I'm going to make some space here. Okay. Okay. So my denominator for all of these is going to be what? 4. 4. 4. All right, you guys okay with that? It's going to be 4 for every one of these. That's an important detail because you're really finding 2 numbers, okay? Now, also here, N of E, how many outcomes are going to be, ladies and gentlemen? I think he's in the next room.
This one?
Yeah. How many outcomes are there when you have no boys? So you got to go to the sample space, and I want you guys to notice something here. Do this. This is an important thing. You see that first outcome? How many boys do you have in this first outcome? Good, 2 boys. How many boys do you have in the next outcome?
1.
Good. What about the next outcome?
1.
And then the last one? Good job. Good. So when they say the probability of having no boys, they're really talking about which outcome? Talking about this GG, is that right? How many outcomes are there? 1. Good job. So ladies and gentlemen, that probability is going to be what? 1/4. Okay, you guys okay with that? Easy peasy lemon squeezy? Nice. All right. Now go to the next one. Probability of having what? 1 boy. Which outcomes correspond to having 1 boy? BG and GB. So how many? What does 2/4 become? 1/2. There you go, ladies and gentlemen. That's the probability of having 1 boy. Okay, so I'm going to go back here and see if we can make it look a little better. There we go. Now, what about having 2 boys? Right? 2 boys. Which outcome? And it'll be 1/4. You are correct. Good job. Look at that, you guys. You guys are doing probability questions. Outstanding. See, you could do this. Okay, you guys know you guys could do this. What's the deal? Okay, now you guys know what happens next. All of the favorite phrases, the language. At least 1 boy. At least 1 boy. What does at least 1 mean? Well, what's at least 1? 1 or more. Remember we did the language? Do you guys know why I did the language worksheet for you guys? Why did I do language? You said you like language. Huh? At least 1. What does that mean?
1 or more.
1 or more. Okay, let's find a color. Which outcomes consist of having at least 1 boy? Well, it's GB, BG, and what? BB. How do we know? Oh, let's not use green. Okay. These are the outcomes that consist of having at least 1 boy. Why? What's the meaning of at least 1? 1 or what? More. So how many outcomes, ladies and gentlemen? 3. Outstanding. 3. Oh my God, look at you guys. Maybe I am glad we showed up today. How's that? Yeah. All right, you guys okay with that? Okay. What about the next phrase? What is this phrase now? What does this say? No more than what? 1. So which outcomes are no more than what? One. What does no more than one mean? One or what? Less. Okay, which should we find? What color? You choose pink. Which outcomes consist of having no more than one boy? BG, GB, GG. How many outcomes? 3. So that's 3 out of what? 4. Okay, you guys okay with that? So what do you guys think? Is that easy? Easy peasy lemon squeezy? Now, should I share with you guys a test question that I once gave? All righty. Good. Maybe I'm glad we are here today, even though everything's crazy. Huh? You made your dad give you a ride?
Yeah, we lost an hour of sleep.
Yeah, we lost an hour. Drink coffee, join the club. I don't think my coffee's kicked in. I'm looking for the outcome where we had 3. Oh, yes. You guys remember this sample space?
Yes, we do.
Having what? 3 children in the sample space? Do you guys remember that one? I once gave on a test. This is what I gave. The 3 children. Let me copy the sample space. Let's copy the sample space. What do you guys think? Okay, so now I'm going to ask you guys this question here. I'm going to say this. What's the probability of having question 1? No girls. Question 2. 1 girl. Question 3. 2 girls. Question 4. All girls. And again, question 5. At least, we're going to say this one, 2 girls. Question 6. No more than what? 2 girls. Okay? So this was a test question once. But this time, the question's regarding what? Girls. Is that true? Do you guys know what I mean? Okay. So let's ask you guys a question on this first one here. You guys can tell me. First of all, how many outcomes are here? Good. Look at that. Boy. 8 outcomes. Outstanding. Did you watch the video I sent this weekend?
I did some homework.
Yeah. Oh my God. Do you guys see how homework helps? Homework is what? The way you do it, ladies and gentlemen. Look at that. Oh, anyway, I'm glad for some good news. BBB is what? How many girls are in BBB? 0. How many girls are in BBG? 1. How many girls are in BGB? 1. BGG? 2. GBB? 1. Good. How about GBG? How many girls here? 2. GGB? 2 girls. And then GGG, how many girls here? 3 girls. Okay, you guys are good with that? Now, when they say to you, what's the probability of having... Now, I'm going to have to kind of make some more space again. No girls. What do I need to know? It's about language. Which outcomes out of the 8? Your denominator is an 8, is that right? Which outcomes correspond to having no girls? Which one? The first one, BBB. So how many outcomes? 1. Probability is 1/8. What do you guys think? Is that okay? Oh my God, that was a test question once. 1/8. What do you guys think? Pretty good? Oh my God, that's amazing. One girl. One girl. Let me change the color and ask you guys, go to the sample space. Which of the outcomes consist of having one girl? Which ones? BBG, BGB, what else? GBB. Is that true? You guys good with that?
There's 3/8.
Yes, it is. Look at that. That's 3/8. Outstanding, ladies and gentlemen. Look at that. 3/8. Is that okay? 3/8? Anybody have any questions on that? Okay. Man, we're going to give all A's this semester? I hope.
Yes.
2 girls.
That is what Carl State Dominguez said.
Which of these outcomes consist of having 2 girls? BGG, GBG, GGB. How many outcomes? 3. Good. Look at that. 3/8. Nice. Oh, man. All girls. All girls. Which of these outcomes consist of having, what do they mean by all girls?
Nothing but girls.
100%.
Yeah, nothing but girls. What do you guys think? Having all girls? Oh, what color? We use orange for the 2, right? So let's be consistent. So now, if we're going to have all girls in green, all girls, they're really talking about what? 3 girls. Is that true? Okay, does that really mean 3 girls? All girls? Okay, what's that probability going to be? How many outcomes? 1 out of what? 8. There's your answer, ladies and gentlemen. 4. Easy peasy lemon squeezy. Okay, number 5 now, ladies and gentlemen, at least 2 girls. So you're going to have to tell me what's the meaning of at least 2 again. 2 or more. Maybe I want to write that down, right? 2 or more what? Girls. Which ones are 2 or more? That means 2 or 3. Is that true? 2 or 3 girls? So out of the 8 outcomes, how many outcomes are 2 or more? Let me share with you guys. Where are they at? Got to find another color. 2. 2. 2. And what else?
3.
The 3. Isn't that 2 or more?
Yes.
Good. How many outcomes?
4/8.
And that reduces to?
1/2.
Outstanding, ladies and gentlemen. Look at that. Oh, man. What do you guys think? Pretty good?
Easy peasy lemon squeezy.
Yes. It's easy peasy lemon squeezy. Maybe it's going to be a good day after all. What do you guys think? Man, that classroom, it's crazy. Well, at 9, she's going to call IT and find out. No more than 2. What does no more than 2 mean? 2 or what? Or less. Did we use pink? No. Pretty in pink. Okay, did you guys ever see that movie? Pretty in Pink? Anybody? Yeah, you guys probably don't know. You guys like Pretty in Pink? No? You ever watch the movie Pretty in Pink? No? Oh, you're not missing much. It's a very famous movie, by the way. I think my daughter likes that movie. Anybody here know what I'm talking about? How many people know what I'm talking about? Pretty in Pink. Oh, man, that's like an 80s movie. It's like a classic. People love that movie, Pretty in Pink. I don't. I never did. No, you guys don't know? Anyway. Something to watch on Netflix. 2 or less. Where is that at? What's 2 or less? Well, the phrase is no more than 2, so that means 2 or less. So which ones are 2 or less? Well, I got news for you guys. The 2s are 2, is that right? What about the less part? 1, good. What else? Outstanding. How many outcomes? Yeah, why do you count 0? Oh, you got pink. Do you like the movie Pretty in Pink? You never seen it? Jeez, man, what the hell? I don't think it's even on Netflix. I don't know where it's at. Is it on YouTube? It might be YouTube. It's so old. Yeah, that's such a big classic. It was really big back in the day, Pretty in Pink. It's one of those Molly Ringwald movies. You say, who's Molly Ringwald? Exactly. Who's Molly Ringwald? Oh, my God. Anyway, well, I'm not a big fan, so it doesn't matter to me. Huh? HBO Max has it? Jeez. I got to end all my, I subscribe to all those, whatever it is. I don't watch anything.
I hate Netflix, so yeah, I
Anyway, how many outcomes? 7 out of? Outstanding, ladies and gentlemen. Yeah, some people are into all that 80s stuff. 7/8. This was a test question once. What do you guys think? Is that too difficult? What did I say you have to know? Your definition, it's language and process. You start with the sample space. You indicate how many boys they're asking, how many girls. And then, you use the definition of probability, but you're going to have to know language, meaning what is 2 or less, no more than 2. And yes, 0 is what? Is less than 2. 1 is less than 2. But they're saying 2 or what? Less. 2 or less. All right. Now, if I had, this is one of my most favorite examples to let you guys know, if I had my laptop, I'd have this all ready, so I'm going to have to do some stuff here. But it's called the Titanic mortality table. Do you guys know what mortality means? It's death. So let me just remark about this for you guys, okay? The Titanic mortality table. It's like people on. Did you watch the movie The Titanic? Oh, okay. So you guys watched that movie.
I saw all 3 versions of it.
There's 3 versions of the Titanic?
More than 3, but yeah, I seen one.
It only hit the iceberg once. How do you have 3? Oh, I see your point. I see your point.
2 people could fit on that door.
Huh?
2 people could fit on that door.
Yes. That's what I always say. That's the first observation I made when I watched the Titanic, the James Cameron version. I'm like, you know what? She could have let him on that. Huh? Whatever that was. Was it a door? She could have let him on that door. Did you guys notice that? But she didn't. Was it a door?
They will sink.
Oh, they would sink? Yeah. So, the reason I'm bringing this up, let's see what you guys think. People study this table, by the way. And the question is chivalry dead? What is chivalry? Anybody know what chivalry actually is? What's chivalry? If you look it up, it's knightly behavior. And what do you mean knightly behavior? Like a knight. So this is where it comes from. So you guys ever hear the phrase women and children first?
Yes.
That's short for save the women and children first. So the Titanic mortality table is studied in terms of probability. Okay, and we're going to look at that table. It's one of my all-time favorite things to look at. I actually even made, if you guys watched that first video I did, it was even there. I even put it there. It's very famous. So let's look it up. You know, I can write it down, but you know what? Let me see. Let me see. It might be that we can find it. Huh? Tell me about it. Gosh.
No, my Wi-Fi at home, it keeps cutting off,
Oh, here we go.
so it works at my house.
So I have to remember my. What? What happened? Hmm? Okay, now let's find it. Let's find a good one. What do you guys think? It's a real good for. Oh, there's Mr. Judge. There's some of my work. I'm going to find a table here. Where was the one I had? Maybe that one. Okay, yeah, okay, we'll try to do that one. Okay. And you guys are, where are you at? Probability, what class are you again? There you go. Anyway. So we're going to start to consider, is chivalry dead? And we probably can't answer that today. However, I'm going to ask you guys, we're going to ask you guys probability questions based on this table here. Okay? I'm going to say, if you select, here's the classic question here. You're going to select a passenger at random. What's the probability of selecting, okay, a person who, question 1, survived. Question 2, died. Okay? This is the Titanic mortality table here. Okay? And we're starting to look at how to read a table here. So if I said to you, a probability question of surviving, what do you guys have to know again? They're asking you, what's the probability that someone survived? So to use that definition, what do you guys have to know? How many passengers survived out of the what? Total. So we have to count. But you guys want to know the good news? These questions are even better than the others. You know why they're better? You don't need to create the sample space. In fact, you don't even need to count. Why do I say that? They already did it for you. They counted for you. No? What do I mean by that? How many passengers survived, ladies and gentlemen? No. You see this over here? See that first row? Oh my God, they told you there's a total. What's the total? 706? So, ladies and gentlemen, do you guys realize there was 706 survivors on the Titanic?
I thought it was 705.
No, according to this table, 706. There's 706 survivors on the Titanic. I just want you guys to know, how many people did not survive? How many? 1,000. You see the total? Right? You're looking at the total here, ladies and gentlemen. You're looking at this right here. So you're looking at this column here. Does that make some sense? So what that means is 706 passengers survived, 1,517 died. How many passengers were on the Titanic? 2,200 and what? 23.
And not enough lifeboats, huh?
So, ladies and gentlemen, the probability of surviving is 706 over 2,223. Now, that's the fraction answer, okay? But what I'm going to now do and say to you guys, you want to approximate this to the nearest thousands. Okay? So approximate to the thousands. Now, because I don't have my laptop back from where? From Apple. You know what? They sent me an email yesterday. They said, oh, it'll be ready on Sunday. So I'm like, okay, I'm going to go pick it up at the Apple store in downtown LA area, you know, whatever that is.
You mean that used to be a theater?
Yeah, it used to be a theater, so I was going to go there and pick it up because that's where I dropped it off. And I got an email that says, oh, you know, we ran some tests, but we're not experiencing the same problems that you actually have. Like, what?
Time to get a Windows.
Then why did you guys send why did Apple send the computer out to you if it didn't have a problem? And they're going to run another diagnostic test on it. Whatever. So what I'm going to have to do is I'm going to have to go to my calculator here, the GCalc. Not now. And clear. GCalc. 706 divided by 2,220 what? 3. Okay? Enter. What do you guys see up in the right-hand corner? Can you guys say, what's this answer to the nearest thousandths position? 0.3. The 7 is in the thousandths position. The digit to the right's a what? A 5. What does that mean? Add 1 to the 7. What do you get? 0.318? Is that right? All righty. Good job. Look at that. So here's what I want to say to you guys. I'm asking you guys to approximate this now. Okay? Because here's your decimal answer. And I want the decimal answer because this fraction is not so easy to simplify. Do you guys agree? You guys know what I'm saying? You can't simplify that. You can give me the decimal answer. But even better, every decimal can be written as a percent. So what is this as a percent?
Do we move it?
Yeah, you move a decimal how many spaces? 2 spaces to the? And what does that give you? 31 point what? Percent. Why am I asking for this information, ladies and gentlemen? Do you guys want to know why do we actually convert to a percent? What's the reason? Do you guys remember? Because when you talk to people, you don't want to say, hey, you know the chance of surviving the Titanic was 0.318? You know what you say? It's 31.8%. There's a 31.8% chance that you survive the Titanic. 31.8% of the passengers actually survived. So if you watch the movie, you might think everybody, what, died. Only a few people, like, what's her name, Grace? Was her name Grace? Rose, sorry. You might think like only Rose survived. No, about 31.8% of the passengers survived.
But Jack passed, well, I don't count those two.
We can't count Jack. What happened to Jack?
He died later.
He died. Isn't that the second question? What's the probability you what? Died. So the second question, we're going to ask the probability that you died is the number who what? Died out of the what? Total. You okay with that? So you already know how many passengers are on the Titanic. 2,223. Good. Of which, how many died? It's in the table. How many died, ladies and gentlemen? 1,500 and what? 17. Okay. So here you go. 1,517 passengers what? Died. Let's see. What is this to the nearest thousands? I don't want you to give me the fraction. I want the decimal answer. And they're going to ask you, hey, what is this? Okay. 1,517, right? Divided by 2,220 what? 3. What do you guys get to the nearest thousands? To the nearest thousands. Point what? 0.682. What is it? What is your answer? The digit to the right of the 2 is a 4. What does that mean? Stays the same. Okay. So this is going to be point what? 0.68 what? 2. This is the decimal representation of the probability, which means 68.2% of the passengers, what happened to them? They died. They died. Okay? 68.2% of the passengers on the Titanic died. So, like Jack was one of those 68.2%. Okay? So I want to ask you guys this question here. See if you guys understand what I'm saying. I want you to compare. I'm going to say, question 3, what's the probability of selecting a boy? And question 4, a boy who died. Horrible questions, ladies and gentlemen, in my opinion. I don't really like that, but we got to talk about it. Is this, what, compare and contrast? You got different events now. What's this event? You're selecting a boy. Is that true? What about the next event? A boy who died. What does that mean, right? Because remember, when you say select a passenger, how many passengers are we talking about? Only one. Is that true? A passenger. That's what we're asking. Selecting a what? A means what again? One. If I offer you a drink, I'm offering you one. If I'm offering you a banana, one. A cookie, one. So there's only one. And then what is this phrase, a boy who died? What does that actually mean? Because you're a boy who died. In this case, you're just a what? You're just a boy. In this case, question 4, compare and contrast. What's the difference? You're a boy, and you what? And you died. Does that make sense? I'm going to say it again. You're a boy, that's fine, and what's the other situation? And you died. D. And that's going to be a big deal for us. Because yes, in both cases, I do know how many passengers are on the Titanic again, right? We know that the sample space has 2,223 passengers for both. You okay with that? All right. What's the deal now? How do we start to answer those questions? Can you read the table? How many boys are on the Titanic? How many?
64.
64 boys. Isn't this, so you guys see down there, isn't that a total, 64? Okay, so this question here is going to be what? No, 64. The probability you select a boy, that's P of B and a B over what? N of S. So you have to know how many boys are on the Titanic. There were 64 what? Boys. How do you know? It tells you they did the counting, but really how do you know? You're actually just reading the what? See that there? You're reading the total. But then you say to me, well, what does that total actually mean? Well, ladies and gentlemen, 29 boys survived. However, what's the deal? 35 boys what? Died. The total is, what's the total? 64, right here. So you're reading the what? The table. Okay? 29 boys survived, because that's the row and column, and 35 boys what? Died, for a total of 64. So if they're asking you, hey, how many boys are here? You say 64. But down here, the definition of probability, you have to be a boy and you have to die. So that's the number of boys who what? Died out of the what? Out of the total. There's your definition. That's the difference. So it comes down to reading the table. How many boys died on the Titanic? 35. What goes on top? 35. You guys okay with that? So you have to do both. Now, I want the what? Decimal representations here. Okay? Anybody have any questions on that? Because that's a big deal. That's a very, very big deal. Just reading the table. In one case, you're counting the boys. The other case, you're counting the boys who what? Died. And in fact, let's say question 5. You're a boy who what? Survived. What does that mean? You have to be a boy and you have to what? Survive. Okay? A surviving boy. Isn't that a better question? Okay, is that better? I would say so. Okay? So you say, what's that probability? Well, the probability of a boy who survived is, you have to count. How many boys also survived out of the what total? Okay? How many passengers? 2,223, of which how many were boys who survived? Go back up here. Can you read the chart? How many boys survived? 29. Okay? Easy peasy lemon squeezy. Okay, so we're going to go to our calculator to approximate every one of these here. Okay? 64 over 223, 35 over 223. So let's try this out. 64 over 223. So 64 divided by 2,223. Okay. And then what was the other one? 35? 35 divided by what? 2,223. What was the last one? 29 divided by 2,223. Okay. We're going to go to the nearest what? Thousands. What was the first one to the nearest thousands? 0.02 what? 9, is that right? 0.029, you guys okay with that? Okay. What is this answer as a what? As a percent? It's 2.9%, ladies and gentlemen. So what we can say is 2.9% of the passengers on the Titanic are who? Boys. Okay? 2.9% of the passengers were boys. Easy peasy lemon squeezy? What about boys who actually survived? Or no, boys who died, sorry. That's going to be, what's this answer to the nearest tenths? Thousands. 0.016. 0.016. Is that true? Okay. So this is 0.016. What does that mean as a percent? 1.6%. So the probability to select a boy who actually what? Died is 0.016. Okay? What about the probability of selecting a boy who survived? Well, that's going to be what? 29. We did that already. Oh, here we go. Yeah. What's that decimal? 0.01 what? 3. Okay? Which makes this 1.3%. So I just want to go through that kind of detail because that's the kind of detail you need to have to answer questions that have tables. You got to be able to learn how to read the what? Table. Okay, you guys okay with that? Anybody have any questions on that part? How do you read the table? Easy peasy lemon squeezy?
I'm gonna take those notes down.
You're going to do what?
I'm gonna take those down, notes down from the website, because right here I kinda messed up here.
Oh, okay. All right, let's check. See if you're awake. Number 6. Who should we pick? Should we pick the men? Okay, I'm going to ask you 3 questions. What's the probability of selecting a man? Number 6. 7. A man who what? Who died? And then question 8. A man who what? Survived. Now remember, in each case, all you're doing, you're selecting a what? Single passenger. So there you go. There you go. There you go. Here are these guys, right? So in the first case, all you have to do is be a what? A man. Okay, you guys okay with that? What about the second case? You're a man who what? So you got to be a man, and you have to have what? Died. Oh, horrible. So you're a man, and you died. What about the third case? You got to be a man, and you have to what? Survive. That's better. You mean there are men who survived the Titanic? Well, maybe. Let's see. You guys see my point? I don't know what color. What color do we use for dying? Was it orange? And what color do we use for surviving? I think it was purple. Is that true? Okay, so I just want to, sometimes it's a lot easier to see with colors. Is that right? Okay. So you guys already know, though, how many passengers were on the Titanic? 2,000 what? So you're going to divide by, let's put that in red. 2,223 for every one of these. That's going to be your denominator for every one of these. You guys agree with that? What do you guys think? Okay? We just have to what? Read the table. So, you guys have that in your notes? Okay. Let's go back to the table. Where's our table? There we go. I want to remind you, 2,223 passengers, in which 706 survived, so you guys can see that there. 1,517 what? Died. But now, what are we looking for? What row, I'm sorry, what column are we looking for? The men. What does that mean? Can you read this? There was 1,692 what? Men on the Titanic. That's just the total men. So far, so good? So 1,692 men are on the Titanic. What does that mean, though? That goes where? Right there. You guys okay with that? Easy peasy lemon squeezy? Okay. The men who died. Uh-oh. Can we read the table? Can you guys tell me? I think I got my colors backwards. Yeah, I think I do. The death is purple. Sorry. A little OCD. Isn't that horrible? Ugh. Died is purple. Survived is orange. Isn't that kind of weird? Anyway. Purple. Yeah. I guess literally, do you guys think you think Jack turned purple? Kind of. It's a bad joke. Okay. Men who died. How many men died? They're in the death row, the man column. How many men died? 1,300 and what? 60. How many men survived? 300 and what? 32. So 1360 and 332. Okay. Is this 1360? Yes. You know how many men survived? 332. What do you guys think? So some men survived. Is that right? Isn't that great that some men survived? 332 survived, but how many did not survive? 1,360. So, ladies and gentlemen, we're going to find all of these values here, okay? Because we're learning how to read our table. Okay. Let's clear this out. Where's clear? There we go. 1,692. Is that 1692 or 1690? 1690. Oh, I was right. How many passengers? 2, 2, 2, 3. What do you guys get? To the nearest thousands. Isn't that 0.761? What is that as a percent? 76.1 what percent? So what does that actually mean, ladies and gentlemen? You know what that means? That 76.1% of the passengers were who on the Titanic? Men. Is that a pretty big percentage? 76.1%. That's almost 3 out of 4, which is 75%. A lot of men on the Titanic. Okay. Men who died. 1360? What is this? 0.61. Is it 1 or 2? 2. Good. 0.612. %61.2%. So, ladies and gentlemen, 61.2% of the passengers, of the men, also died. All right, what about survive? 332. .14 what? 9? 0.149. Which means 14.9 what percent? Okay. Okay, you guys okay with that? So there you guys go. A very interesting setting, table of probabilities. What do you guys think? Is that good? Easy peasy lemon squeezy? Alrighty. Okay, ladies and gentlemen, what's the deal now? I'm going to give you guys another question here. One of my favorite examples for probability, a bag of marbles. Now, the question is always, is it marbles or marbles? Huh? Well, it's actually done It's spelled like marbles. Here's a very simple example with probability. It's one of my favorite examples. I'm going to say you have 8 red marbles, 4 green marbles, 3 blue marbles, 2 yellow marbles, and 1 orange marble. Okay? Red, green, what else? Blue, yellow, and then what? Orange. If you select a marble at random, okay? All these questions are selecting a item. What's the probability of selecting the following marbles? Let's see what you guys think. 1. So probably select red. And then 2, I'll say green. Okay? It's a very, 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 very simple question. You don't have to approximate your answers to the thousandths or anything. We're going to keep it as a fraction. Okay? And let's see if we can use the definition. What's the definition? The probability of selecting a red marble, what do you guys have to know? You got to use, this is a probability question. Notice, do you have to create a sample space? Say no, your sample space is already here. So these questions are easier, not harder. But what are they going to make you do? They're going to make you what? They're going to make you count. Tell me about it. Like, oh, my life's over, Mr. Judge. They're going to make me count marbles? Okay, you get to use a calculator. What's 8 plus 4 plus 3 plus 2 plus 1? You get to use a calculator. Well, how many?
18.
There's 18 marbles in the bag. So you want to know what's going on? The denominator is 18. Is that true? Okay, now, what else do I have to know? How many are what? Red. How many red marbles are there? 8. So what's the probability? 8 out of 18. Do you have to reduce your fraction? Yes. 2 goes into 8 how many times? 4. 2 goes into 18 how many times? 9. Ladies and gentlemen, the probability is 4 over 9. What do you guys think? Is that hard? No? Pretty easy? Pretty simple? What do you guys think? Pretty good? Okay, what about green? Probability of selecting green. What's this? Number of green marbles out of the what? Total. How many marbles here are? There's how many marbles? 18. Of which, how many are green? How many marbles are green? How do you know there's 4? They're telling you there's 4. So you just have to know your definition, and there you go, ladies and gentlemen. 4 out of 18. Now, can you reduce that? That's 2 over 9 now. Reduced fraction. Easy peasy, lemon what? Squeezy. Good job. What do you guys think? Okay, so far so good? Now, I'm going to give you a hard question here. Number 3. What's the probability you select a red and a green marble? So remember, that marble you select, because you're selecting one marble here. Okay? How do you know it's 1? Probably you select A what? A means 1. Okay, so this is kind of a trick question. I want to see if you guys are awake. It's a trick question. Red, green. It's a trick question. They're asking you now, that single marble has to be what? Both red and what? Just like the boy had to be a boy and die, a boy and survive, a man and die, a man, man and survive. I'm forgetting. Your marble has to be red and what? Green. Oops, that's not green. Red and green. So look at your bag of marbles. Here's the bag. How many marbles are both red and green? Red and green. Is anybody here wearing red? No, I don't see anybody. Anybody here wearing green? No, I don't see anybody. Okay. Darn it. How many marbles are red and green in this bag?
Oh. Okay, no. 8. 4.
0.
Shoot, because you're not.
0, ladies and gentlemen. So what's 0 over 18? That equals what? 0. Okay? Now let me get back to the point I'm making here. It's very simple. When they tell you you have 8 red marbles, what do they mean? They're solid red marbles. When they say you have 4 green marbles, what do they mean? They're solid green marbles. You're asking for a marble over here that is both what? Red and what? Green. You're selecting a single marble. Are there any? No. You guys want to know? Let's put a note here. You want to know what you're really answering? Red or what? Green. Okay. So red or what? Green. You see, ladies and gentlemen, yes, if you said there's 8 plus 4, which is 12, that's going to be 12 over 18, and that reduces to what? 6 over 9, I think, yeah, and that's 2 over what? 3. Double check my arithmetic. You see, what's going to happen is you're going to need to know the difference between what 2 words? Yes, and or. Remember I said language and process? And is not the same as the word what? Or. I'll say it again. And or are 2 different words. If I said to you guys, if I say to my daughter, right? Anybody here a Disneyland freak? Where's the Disneyland freaks? I can already spot 1, 2, 3. There are people who are Disney freaks, okay? Disneyland, I don't know about you guys. That's like the worst. Anyway, so here's what I used to say to my daughter to leave you guys for the day. Ashley would always want to go to Disneyland. And I'd say, Ashley, if you go to Disneyland, if you clean your room and you eat all your vegetables. What does she have to do? Both things. If you're selecting a marble that's red and green, it's a marble that's what? Both colors. You got none in that bag. Easy? What about the word or?
The choice.
Or now, if I said, Ashley, you could go to Disneyland if you clean your room or you eat your vegetables. You know what she could do? Just clean her room. Just be red for the or. Or, what else could she do? Eat her vegetables. She just has to do one thing. Really, she has to do at least one thing. What if she did both? Is that okay? See, this is the meaning of what's called an inclusive or, ladies and gentlemen. So we're going to continue with these questions when? Tomorrow. Now, I can't tell you what room we'll be in. Okay, I can't because God knows what's going to happen. I mean, it's already insane. I'm already in the place I shouldn't be, but I had nowhere else to go. So I told the secretary, hey, secretary, this is happening. She's calling IT. Hopefully they fix the problem. I don't know where we'll be tomorrow. Maybe here, maybe there, maybe somewhere else. I have to check later on today.
That's why I always check Canvas.
Okay? But I'll try to communicate via Canvas. That's why you guys have that on your app. On your phone. That app. Okay? I'll see you guys tomorrow.